we will get started. So in today's session, we're going to look at the active-active failover first in routed mode, then talk about transparent firewall on the ASA, and look at the other variations of doing failover in transparent single context mode, and then also in transparent multi-context mode. So as I mentioned, the mode of the firewall, whether we're doing routing or transparent, and then the context mode, those are mutually exclusive. So you can have any variations of them. The limitation, however, is that in the versions we are running in ASA code 8, you cannot do a mix between routed and transparent when you are running multi-context. So in other words, either all of the contexts are routed or all of the contexts are transparent, but no mix of them at the same time. Now, up to this point, we already talked about the active standby failover, and the main difference here with the active-active failover is that there's going to be one unit that is active for one group of contexts, and then another unit that is active for a separate group of contexts. So technically, this is still active standby failover. It's more of like a marketing term that it's active-active. We do not have multiple active forwarders for the same context. So as I mentioned before, it's not like GLBP as your first hop redundancy protocol where you have multiple active forwarders on the segment. We're basically saying if we had context A and B, we could have one physical box forward for A, the other physical box forward for B, and then we would get some load distribution between the two of them. But if we're running in single context mode, then it's not active-active, it's active standby. Where here with this configuration, what we will see is that it is actually active standby on a per context basis. Now, this is also going to introduce the notion of the failover group. The membership of the failover group to the context is going to determine which particular context that individual ASA is forwarding for. And these are going to be defined in the system context. So we looked at previously what are the attributes that we define under system versus the user context. Anything that is a physical attribute of the box, like the number of connections a context can use, or in this case, the failover groups, that's going to be configured under the system context. Then we'll see that there are some options that we need to configure under the user context if we want to do monitoring of the interfaces in the data plane. So we saw with the previous failover configurations, we have the failover link itself that is used to pull the devices back and forth to see, is the active unit still up? Does the standby one need to promote itself to the active status? But that's still not polling the actual data plane interfaces, like the inside or outside. So in our particular case with active-active failover, the data plane interfaces exist in the user context, and the failover interface is going to be defined in the system context. So the logic can get a little bit confusing if we don't know exactly how this is pieced together. And that's what we're mainly going to focus on in this section, is how do we actually implement this. Now for the failover groups, there's only going to be 2 of them. It doesn't make any sense to have more than 2 groups because there's only 2 devices in the failover pair. So we cannot have 3 or more ASAs that are doing failover together. It's always 2. It's always a pair of identical devices. We'll also see that we still have the admin context, which is going to be used for our remote access. That's going to be part of failover group 1, and this is not going to be configurable. So only one of the devices is going to be accepting management connections, and those management connections are going to go into whoever is active for failover group 1. So let's take a look back at our topology that we were working on. And right now we have ASA1 that is running in multi-context mode, and it has 2 different contexts. We define context A that goes over to router 1, and we have context B that goes down to the test PC. The link that goes to router 2, this is the outside interface that is shared between the contexts on ASA1. So we have the outside interface 136.1.215.115, which is part of context A, and then the interface 136.1.215.215 that is part of context B, but they're both sharing the same physical interface, or in this case, the same logical interface, that E0/1.215 subinterface. Now, the configuration isn't really going to change whether we had unique interfaces or whether we have shared interfaces, but remember the logic problem that we ran into before. If you are using shared interfaces, you need to make sure that the ASA classifier is able to send the traffic out, and when the flows return, it needs to be able to figure out what particular context does it belong to. So in our particular case, we did this just by assigning unique automatic MAC addresses to the outside interfaces. But of course, we could have done this with statically configuring the MAC addresses, using unique physical interfaces, or using the network address translation so that we had unique identity NATs essentially in order to solve the classifier problem. So next, let's take a look at the current configuration and make sure that everything is functional before we move on to our failover. So on ASA 1, we can see in this output here we have the show mode and the show firewall. So it says that we're running in multiple context mode and we're running in routed mode. If we look at the show contexts, we have 3 different contexts defined. The admin one, which is our remote access context, then A and B, and we can see what the interface allocations are. Okay, if we go to the devices that are behind the firewall, like on router 1 should be able to send connections through the firewall. So if we were to telnet to 136.1.215.2, we could see that that connection is successful. If we go to ASA 1, let's say change to context A, and if we look at the show connections detail, we should see that telnet session that router 1 was initiating. Now additionally, for a little bit more simplicity of this verification, I'm also going to edit the inspection policy in order to allow the ASA to let pings through from the inside to the outside. Because as we talked about before, with the default modular policy framework inspection policy, TCP and UDP is inspected, but not ICMP traffic. And we can see this under the individual user contexts if we look at the show run policy map. And we see our default global policy, which is not inspecting ICMP. So I'm going to add this in here under the inspection default class, say to inspect ICMP. Then I'm going to change to context B and essentially do the same thing. So under the global policy, we want to inspect ICMP. Now here, this is the main difference between the single context mode and the multi-context mode, is that we essentially have 2 different instances of the virtual firewall or of inspection. So when we make a change in the policy for context A to say inspect the ICMP traffic, this does not affect the inspection policy for context B. So keep in mind that those are separate. That's the main point of doing the multiple contexts, that we're virtualizing the inspection engine. Okay, next if we go to router 1, let's try these pings. So we should see now that this is successful, which it is. And let's also check it from our virtual machine here, the test PC A. So test PC should be able to ping 136.1.215.2, which it can. So again, we always want to do a basic verification of these type of basically the state of the network before we get into any upper layer configuration, because we don't want to be troubleshooting something that's in failover and then realize that the layer 2 VLANs were configured improperly, or something very basic is wrong with the ASA. Now when we looked at the active standby failover, the other thing that we have to take into account is that the other device that's going to be part of the failover pair, we have to remember that it needs to also have an identical set of these interfaces in the data plane. So it likewise is going to have E0/1.115, it's going to have E0/1.215, and it's going to have E0/0. So however these are configured on the layer 2 switches, we need to figure this out from the underlying physical wiring topology and then make sure that those configurations are on a one-to-one basis. So if we look back at our physical topology here, on switch 1 and switch 2, where ASA 1 and ASA 2 are connected, we again basically need to make sure that whatever configuration is on this link is identical on this one. And same here and here. So let's verify this real quick before we go on to the rest of the failover. Let's go to switch 1 and let's show run on interface F1, 0, 13, and 15. So both of these interfaces are trunk ports. They're both including the same number of VLANs, which is the inside and the outside that we're using on the ASA. Then let's look at on switch 2. This is going to be ports F1, 12, and 14. So 12 and 14 need to be identical. And then we're going to use E0/2 as our failover link. So that's going to be on ports 13 and 15. We need to make sure that this is identical. So here, this VLAN 999, this is any arbitrary number that we're not using on a different segment. It just needs to be for link local communication between the ASAs. So we don't need to be trunking this to the other switches. Basically, nobody needs to know about it except these 2 ports locally significant here. Okay, so next let's take a look at the documentation example so we know where this would be located. So from the main documentation page, we're going to go to Products and Security, Firewalls, ASA, 5500, Configuration Guides, then 8486. Then this is going to be under High Availability and Configuring Active-Active Failover. Now, as I mentioned before, depending on what particular version that you're looking at, this may be documented under multiple context mode, or the active standby may be under single context mode. The move to 8.4 moves some of the documents around. So make sure you do spend some time going through the documentation so you know manually where the navigation path is. Because again, in the exam, you do not have access to the search. You need to be able to find all the documents you need manually. So basically, most of this is going to be the same, similar to the active standby, but if we look at the flow of tasks, so basically the step-by-step list of what we need to do, the main difference is that the monitoring of the data plane links is going to be done under the user context and not under the system context. So it says configure the primary unit. So we say this is the primary, this is the link we're using for failover. And remember the difference between the failover LAN and the failover link commands. This is for the regular stateless failover, so this is required. The other option, which is the failover link, this is the stateful failover. This is the optional one. So this is when we're going to be replicating the connection table. And in this case, it's going to be on a per context basis because we're doing active-active. Okay, so again, our steps here, if we, let's go ahead and write these out in our text editor here. We basically say that the first one is going to be the primary unit. We specify what's the interface we're using. This is a name that we're giving it. I'll call this failover. And in our case, we're using interface E02. Then what's the address of the link? So the primary address and the standby address. Again, this is only locally significant, so this could be any arbitrary value, 10.0.0.1 and 10.0.0.2. This segment, or this address here, it does not need to be reachable from any other device in the topology. It's only a link local address between the two of them. Okay, then if we want to do stateful failover, we specify the failover link. I'll call it failover again. And this is E0/2. And remember, these could be 2 separate interfaces. In my case, I'm using the same ones. But in a normal design, you would want to keep these separate. And then the failover interface, again, this is optional, saying if you're doing stateful failover on a separate interface, you would also need to configure an address. But in this case, since I'm using the same one, we already have the IP address configured. Okay, then last step is to, of course, the interfaces need to be not shut down. And here's the other difference in the config. So we specify the failover group. So are we the primary for that group or are we secondary? And then we're going to go to the contexts and specify which context belongs to which group. Now, to start here, I'm going to say that ASA1 is going to be primary for both of these groups. So we'll say that we have failover group 1, where I am the primary, and we have failover group 2, and we are the primary. Then we have our two different contexts. We have context A and B, and then they are going to join the failover groups. So context A is joining failover group 1. Context B is going to join failover group 2. So however we want to do the load distribution between them, the way that we do that is just assign them to different failover groups. So if we have 10 different contexts, we may want to say 5 of them are in group 1 and the other 5 is in group 2, or however we want to do the distribution. But remember, regardless how many contexts there are, there's still only 2 failover groups because there are only 2 physical devices in the failover pair. So one of them is active for some set of contexts, the other one is going to be active for whatever other contexts are left. Okay, then last but not least, we turn failover on. But we want to make sure that we don't do this until all of the configuration is staged. Okay, so let's start this first on ASA 1. Let's change to System. And just to make sure, in case I make a mistake, I'm going to say write mem all first. So this is saving my system context, the admin context, and then all of the user contexts. So again, when you're running in multiple context mode, you want to get into the habit of using this command, write mem all, not just copy run start or not just write. Okay, next let's go ahead and do the same thing on the other side. And additionally, I want to look at the show interface IP brief and make sure that the links are actually up. So we see E0/2, this is the failover link. And on ASA2, we're going to do the same thing. So we see on the output here, it's in multiple context mode and it's in routing mode. So we do need to make sure that these agree before we configure the failover. So if one of the boxes is in single mode, the other one is in multiple mode, then they're not going to be able to properly join the failover group. So on the other side, basically everything is the same, except that is going to be the secondary unit. And the same is true for the failover groups. And actually here we don't have the context configured. We can wait for this until we fail the configuration over. Then we can go back under the context and specify which particular groups they are in. Because as it stands now, if we look at the show run, there is basically no other configuration on this box. If we look at the show context, we don't have the admin context configured, we don't have context A or B. Okay, if we look at the show interface IP brief, I want to make sure that those links are up. So let's just say no shutdown on all of these. Then I'm going to turn failover on the primary device. And ideally we should see it detect the secondary device. And then it should say that we're going to replicate the configuration to the mate. Okay, this means that we're failing over in the correct direction. Again, the potential issue with this configuration is that if you do it in the wrong order, you could have the secondary one elect itself as primary and then fail the configuration over in the reverse direction. So essentially we could have taken that blank config that was on ASA2 and then overwritten the configuration that was on ASA1. So this is one of the reasons I made sure to save the configuration before starting the failover, because if I did it in the wrong order, worst case scenario, I can just reboot the box and it's going to come back to the well-known working config. Otherwise, if I hadn't saved, then I may have to go back and redo a lot of the configuration. So be very careful with this. Okay, notice here it says that for groups number 1 and 2, I'm not getting a response from them. This is actually okay in this case because we haven't yet configured the group to context mapping on the other side. So if we look at the show failover on ASA1, we should see that we know about the other box. So for groups 1 and 2, we are primary and we are active. And for the secondary box, they are standby for the other ones. Okay, next let's go to ASA2 and let's see what did it learn from ASA1. Okay, we could see it learned what the admin context was supposed to be, and then it created both contexts A and B. So let's now say show run context. We could see it told it to join the particular failover groups, and we're now going to say that for, let's say, show run failover. Actually, let's say show run pipe begin failover group. We're going to say failover group 1, we are the secondary. Okay, same for failover group 2. The other box is the primary one. Now again, as we talked about here, one of the disadvantages of doing the failover is that now the host name is equal between the two boxes, and it might get a little bit confusing where we need to do our changes. Because we saw when we went into global configuration here, one of the things that the ASA told us is that we shouldn't be doing configuration changes because the config is not replicated from the standby to the active. It's only replicated from active to standby. So to fix this again, we can go to global config and say the prompt, I want to include my host name, but I also want to include my priority, my state, and my context. So this says I am a primary and I am the active box. Then if we say change to context A, we can also see whether we are in context A, B, admin, etc. Okay, if we do the same thing on the other side and change to context A or B, we can see that we are standby for both of these. Now, if we look at the show failover again, there's two different views that you can see for it. One of them is going to be under the specific context. So here we're looking at the show failover view from context B. Or there's a second view that is under the system context. So looking at the failover config under the system context, this is going to tell us the overall state of the system, admin, plus all of the user contexts. And really what we want to know from here is to say show failover pipe include group or the host. So I just want to know who am I and who are they, who is active, who is standby. Okay, so this is active standby for one group and then active standby for another group. So again, on a per group basis, we only still have one active forwarder. But if we were to go to the second box and change it to active for group number 2, then we would have active forwarding. Okay, so to do this, let's go to ASA2 and let's change to system. We're going to make ourselves active, but we're going to make ourselves active specifically for group number 2. Now notice this doesn't change the prompt for the system context. But if we now look at that output again, show failover and look at the group and the hosts, we are now active for the first context while they are standby, but we are standby for the second group of contexts and they are active. So this now gives us our active failover. When you're looking at the active standby failover, you would see that it does not list the group numbers, which means that you could be running failover with multiple context mode, but you're running it in active standby as opposed to active. So it's only considered active when you define these groups, the failover groups, and then assign them to the individual contexts. Now again, what you have to watch out for here is when you're making changes to the user contexts now, you need to make sure that you are on the correct box. Because on this one here, if I change to context A, notice that I am active for A. But if I change to context B, I am standby for B. So this means that if I go into global config here, it's going to tell me not to do that because any changes I make on the standby device for that context are not going to get replicated. Now the opposite would be true on the other ASA. If we change to context A, we are standby, But if we change to context B, we are active. So again, this is why it's a good reason to change the prompt there so you can see which one is active on a per context basis. Now additionally, if we change back to system and look at the show failover, one of the other things that we'll notice is that these interfaces inside of the contexts are not getting monitored, and the ones that are monitored, they don't actually have the keep alive working. So why would this one show unknown and waiting for context B? Okay, let's actually go into the context mode and look at the config. So let's change to context A and show run. We can see that we have our primary address configured, but we do not have the standby address configured. So again, as I mentioned, the vast majority of the failover config is going to go in the system context, but if we want to do monitoring of the data plane interfaces inside of the user context, that's where we need to specify the standby addresses. Because in system context, there's nowhere that we can put an IP address config other than on the failover interface. So this means we would want to go to these two interfaces, and let's say that we have the standby address, 136.1.115.16, and same thing on the other one, 136.1.215.16. Actually, let's say 116. And this is going to be for context A. We want to make sure that we are on the active box to make this change. So we have now the primary and the standby addresses. And we're going to turn the monitoring of the interfaces on. So monitor interface inside and outside. On the other box, we're going to do this inside context B because it is the active one. So if we show run, we need to basically do the same thing here. So we're going to have the standby address, we'll say 10.1.0.16. 136.1.215 to 16. Then let's monitor interface inside and outside. And then let's jump back to the system context. So change to system. And let's look at just the full show failover. So from here we should see now that the inside and the outside interfaces, both of context A and B, go into this normal monitored state. So right now we're waiting for these ones to converge. And let's look at that again. If we show, let's say show failover, pipe include host or group or monitored. So we can see both the primary and the secondary box are polling all of the interfaces. So next, let's save our config. Let's say write mem all. And let's actually test this out. So we know now that since we're monitoring the traffic in the data plane, or monitoring these interfaces in the data plane, if we were to cause some failure, like if we just shut the interface down, of course that's going to cause the failover to occur. But let's say that we go to the layer 2 switch, so the switch that's attached here, and let's say that we remove VLAN 115 from forwarding towards ASA 1. So ASA1 is currently the active forwarder for context A, and ASA2 is the active forwarder for context B. So if we go to that particular port, which would be switch 1, port 13, and I'm going to remove VLAN 115 from that link. So this one right here. Let's say switch port trunk allowed VLAN remove 115. Now before I actually do this, let's go to router 1 and do a telnet through the firewall. And we can see that the connection to router 2 is open. Okay, once we remove this, we should see that router 1, the connection is hung because it's doing the failover right now. And we should see once they figure out that this inside interface, so we can see it's going into the testing phase because it knows that there's something wrong with it. Then we should see this move from testing to failed. And ASA2 should take over the active state for group number 1. Okay, there's a question here with the write mem all, does it save the configs at the context as well? Yes, it does. Okay, that's the reason why you want to say write mem all as opposed to just write. And you'll see this write mem all, it's saving the system context, the admin context, and then each of the individual user contexts. Because these have different configs files, these are not stored in NVRAM now, these are stored on the flash disk. So let's see what happened. Why did it not fail over? We can see that this interface, it says it's unknown. And the other side, it says it's normal, but they didn't actually do the failover. So let's look at the full show failover output. And I'm not sure if it's going to show us that config here. Show failover group 1. What I want to see here is what is the interface monitoring policy. Okay, let's actually go into that context. Let's change to context A. And let's say show run failover. Show run all failover? No, show run interface, is it interface policy? Let me take a look at the command reference. Not 100% sure where this gets changed. Does it go in the system context or the user context? So from here, let's look for the keyword monitor. It says disabling and enabling interface monitoring. It says monitoring of physical interface is enabled, subinterface is disabled. It says the ASA sends hello packets out each of the data interfaces to monitor the interface health. If it does not receive a hello packet from the corresponding interface of the peer for over half of the hold time, the additional interface testing begins. So again, as I mentioned, it starts with very basic testing, is the link up, and it goes into pings and other tests to figure out, is it my problem or is it their problem? Decreasing the poll and hold times enables the ASA to detect and respond more quickly, but may consume more resources. So you can go under the failover group and specify what's the poll time, but there is a default value for this, so we don't need to necessarily specify it. What it's going to be here is probably here for the failover group, what's the interface policy? And I'm not sure if it's going to show us what the default is. So from the system context, let's change to system. Let's say show run all failover. It says the interface policy is one link. Failover group 1, interface policy should be one of the failed interfaces. Now, I'm not 100% sure why it went to unknown waiting as, or no, it went to unknown monitored as opposed to fail. So let's do this. Let's just go to the switch and flap the link. It should detect this almost immediately. No link. Then if we show failover pipe include host or group or monitored, we can see that this host says that it is failed. So the other one takes over the active forwarding for both of the groups. So again, you can trigger this manually. We could have gone to the other box and just said failover group 1 primary, failover group 1 active, failover group 2 active, and we would have seen ASA 2 take over that state. But you also want to check that it can actually figure out these failures in the data plane, because there may be a case where your layer 2 configuration looks like it's working, but when you fail over to the secondary one, if you have your VLANs configured wrong or maybe you're trunking a loud list, then you might not be able to actually forward traffic through that particular box. So if we go back to router 1, we should see that now the connection to router 2 resumes. This is what tells us that the active-active failover was stateful. So on ASA 2, if we change to context A and look at the show connection detail, it should know that router 1 had that telnet session open to router 2. So again, from a configuration point of view, if we show run failover, there's not that much of a difference between the active standby config and the active-active config, but we have to make sure that when we define the failover groups, those are bound to the context, because you can configure active standby failover in multiple context mode, and that's probably not what you are looking for. So if you compare the previous output that we had in the active standby to this output, the show failover in active-active, it says the host is active or standby on a per group basis.